All right, hey everybody, and let's talk about circles in our conic section unit, okay? If you take a look at our objectives, first off we need to write the equation of a circle, and we also need to be able to graph circles on the coordinate plane. Okay, then we also need to take those equations and then graph them. Okay, so I could give you a center and a radius and say find the equation and graph, or I could give you the equation and say just graph, okay? So if you take a look here, we're still going to call the center of the circle HK. So we've used H and K for the vertex of a parabola, and we're going to use it again this time for the center of a circle. And we're going to use little r for our radius. This xy that you see here is any point on the circle. That's why we give it a variable, xy. It could be anything it wants to be. Now, part of your standards is actually to derive the formula for the equation of a circle. Now, I know you probably just groaned out loud. I can't believe we're doing this again, and this time we have to do it for a circle. It's actually not as bad as the parabola, and here's why. Okay, we have the distance formula here. The distance from H to K is R. So instead of having D, we're going to have R. And then HK and XY are going to be our 2-point values. So let's call this X1, Y1 and X2, Y2. So you're going to plug in X for X2, X1 you're going to plug in H. For Y2 you're going to plug in Y, and for Y1 you're going to plug in K. And this is what it's going to look like. Now, in order to get all of this, the square root off, all you have to do is square both sides, because square and square rooting is the opposite of each other. So you're going to be left with r squared equals x minus h squared plus y minus k squared. Believe it or not, that's it. That is the formula for the equation of a circle. So you just derived, whatever, how do you say that word? Derived, I don't know. Anyways, you were able to take the distance formula and derive the equation of a circle. Alright, so again, the equation of a circle with a center HK and a radius of R is x minus h squared plus y minus k squared equals r squared. So the two things you need are the vertex, which is your h and k, and you need your radius, which is the r. Alright, so let's write a couple equations. This says, given that the center of the circle is at the origin, or 0, 0, write the equation of the circle with the following radii. So we're going to plug in, we're going to take this formula, plug in 0 for h, 0 for k, and in this one we're going to plug in 3 for r. So let's do that. X minus 0 squared plus y minus 0 squared equals 3 squared. So really we just have x squared plus y squared equals 9. That is the equation of a circle with the center at the origin and a radius of 9. For this next problem, it's going to be the same thing. Center is still at the origin, but this time a radius is square root of 5. So we'll have x squared plus y squared equals the square root of 5 squared. Now, remember, square root and square are opposites of each other, so this is just going to be x squared plus y squared equals 5. Okay, so that is the equation of that circle. Alright, so here's a you try problem. Please try this problem and pause it. Hopefully you have done this problem. You are now unpausing the video. Okay, the origin says 0, 0, so I have an h of 0 and a k of 0 and an r of the square root of 13. So x minus 0 squared plus y minus 0 squared equals the square root of 13 squared. So simplify, x squared plus y squared equals 13 is the equation of a circle with a center at the origin and a radius of the square root of 13. Alright, now we have some different problems. These are not going to have the origin as their center. In fact, most of our problems won't. So we have an h of 2 and a k of 5. So we have x minus 2 squared plus y minus 5 squared equals 3 squared. All I did was plug in h, k, and r into the formula for a circle. Now remember that this formula is on the formula sheet. It's under conic sections right below the vertical and the horizontal parabolas that we discussed in our previous videos. So all we have to do is simplify this 3 squared to a 9, and we have our equation. All right, with this one we have an h of 0, a k of 4, and an r of 8. So we have x minus 0 squared plus y minus 4 squared equals 8 squared. Now this x minus 0 squared is really just x squared, and the 8 squared is really 64. So the equation is x squared plus y minus 4 squared equals 64. All right, so let's do another problem. H is negative 3, k is 1, and my r is 2 square roots of 7. So we have x minus a negative 3 squared plus y minus 1 squared equals 2 square roots of 7 squared. Now notice all I did in this part is just plug in what I know. I've not tried to simplify anything just yet. Now I'm going to begin the simplification process. X minus a negative 3 is the same as x plus 3. Y minus 1 squared can't be simplified, so we leave it alone. And then 2 square roots of 7 squared in your calculator. Make sure you put the parentheses. If you do not, you're going to get the wrong answer. I want you to try it in your calculator right now. What you should have gotten is 28. If you did not get 28, you forgot to put your parentheses around the 2 square roots of 7 before you squared it. So this right here is your final answer. If you got 14, you know you forgot the parentheses, okay? So x plus 3 squared plus y minus 1 squared equals 28. All right, so we're coming up on a you-try problem. Go ahead and pause the video and give this a shot now. So we have an h, a k, and an r. If you haven't finished the problem, you need to still pause it, and then you can unpause and watch the answer once you're done. So x minus h, which is 7 squared, plus y minus 0 squared equals the square root of 5 squared. So I have x minus 7 squared plus y squared equals 5. All right, now let's get into problems that we don't have the radius. We have a center at 0, 2, and we have a point on the circle 3, 6. So I know that from the center to any point on the circle is my radius. So what we can do is we can actually use the distance formula to find the radius here. So let's go ahead and we labeled our point 0, 2, 3, 6. Let's say x1, x1, y1. Oops, that looks like an x. Let's fix that. And x2, y2. So the distance formula is going to be the square root of x2 minus x1 squared. And remember, this is on your formula sheet, so it's not something that you're required to memorize. Plus y2 minus y1 squared. So our radius is going to be equal to the square root of x2, which is 3, minus x1 is 0 squared, plus 6 minus 2 squared. So where I got these numbers from were from the center and from the radius. So when I type this in my calculator, I'm going to get the square root of 25, or 5. So I have a radius of 5 and a center at 0, 2. So all I have to do is now, with the information, I have my h, my k, and my r. I can do x minus 0 squared plus y minus 2 squared equals 5 squared, which when we simplify this is really x squared here and really 25. So that is the equation of the circle that has a center at 0, 2 and has a point out on the circle at 3, 6 because the radius is 5. Now if you don't like the distance formula, I'm going to show you another method. I'm going to get a line tool here. What's really cool is we can actually use Pythagorean's theorem because this is on the coordinate plane. So I go up 4 units and over 3 units. So this is really the square root of 4 squared plus 3 squared. And that gives me the 5 I need here because this is a right triangle because it's in the coordinate plane. Okay? Because you could say is my radius, so r squared equals 4 squared plus 3 squared. Well, r squared equals 25, so r has to be 5. So the distance formula is just another way to use how to figure it out, or you could use Pythagorean's theorem since it's in the coordinate plane. It's up to you, it's your choice. Alright, so let's do another one. Center at 4, -5, and the point on the circle is going to be -2, 3. So we got a pretty big circle here. Alright, so we have x1, y1, x2, y2. So the radius is going to be equal to x2 minus x1, so x2 minus x1 plus y2 minus y1. So be careful here with that double negative, okay, because that's actually going to be 3 plus 5 squared. So just type in your calculator the way you see it. You should get the square root of 100, which is 10. So with a radius of 10, an h of 4, and a k of -5, I can write the equation, x goes first, x minus 4 squared plus y minus k squared, which is -5, equals 10, my radius, squared. So we're going to change this y plus a -5 to a y plus 5. Two negatives make a positive. And change the 10 squared to a 100 because 10 squared is 100. So what you see here is the final answer for this particular problem. Alright, we have one last problem. It is a you try problem, so please pause the video now. Once you have it done, unpause it to check your answer. Alright, you shouldn't be watching unless this problem is done. So let's go ahead and talk. The center's at -3, 4. And a point on the circle is -1, 1. So we have a very small circle as compared to the previous problem. So we have a center at -3, 4, and a point on the circle -1, 1. So let's go ahead and work on this. Get our point values. Let's say x1, y1, x2, y2. So the radius is the distance from the center to any point on the circle, x2 minus x1, careful with the double negatives there, squared plus y2 minus y1 squared. Now you could have flip-flopped this. You could have said -3 minus -1 and 4 minus 1. It'll still work out the same way as long as you have correctly identified point 1 and point 2. So r is going to be equal to the square root of 13. We can't simplify the square root of 13, so we'll leave it alone. So we have an h of -3, a k of +4, so it's x minus a -3 squared plus y minus 4 squared equals the square root of 13 squared. So this really becomes an x plus 3 because it's a minus a negative. And the square root of a square root of 13 leaves me with just 13. So the final answer is x plus 3 squared plus y minus 4 squared equals 13. Alright, that's it for writing the equations of circles. I hope this helped. I'll see you guys later.